Hello guys and welcome to Freebird's Crew, and in this video I will tell you about the interview questions of machine learning. So if you are going to prepare for the machine learning interview, then these questions you should know. Okay, let's start with our first question, that is difference between machine learning and deep learning. So machine learning enables you to make decisions based on the past data. It only needs a very small amount of data for the training. It works very well on the low-end systems where you don't need large computing systems. Okay, but if we talk about the deep learning enables us to make decisions by using the artificial neural networks that understands the data and patterns just like the human brain. Okay, and it needs really a large amount of data to train, and it works very well on the high-end computing machines where you need GPUs, DPUs and high-end computing services as well. Okay, and this kind of a difference will show that how machine learning and deep learning actually works. Okay, so I hope you guys completely understand that what is the difference between machine learning and deep learning. Okay, so before going ahead, please subscribe our YouTube channel, and so that we can bring more videos to you about interview questions of the data science, machine learning, Python, AI, statistics as well. Let's start our second interview question, that is, what is overfitting and how to avoid it? This is the most important question. So overfitting occurs when a model learns the training data too well. It learns every fluctuation, every noise in that data as well. This impacts the model's ability to generalize, and also it does not apply the same kind of training to the new data. So in that case, your training error will be very low, but your test error will be very high. Your bias will be low, but your variance will be very high. Okay, so our next question is how you can avoid it. Okay, so to avoid the overfitting, you can use these kind of techniques like regularizations. You can apply ridge regression, lasso regression as well to do the feature selection or feature removal, or any kind of techniques that are used in the regularization. You can make your model simple, because in the past your model is too complex. That's why your model is overfitting. But if you make the model simpler with fewer parameters, with fewer columns, it can reduce the overfitting as well. You can also use the cross validation as well. You can use the some model parameters as well, like you can use the various kind of model arguments as well, like in the random forest there is maximum depth and minimum number of leaves. This kind of parameter you can use. Okay, so in that way you can avoid the overfitting as well. Okay, so the next question is how can you choose a classifier based on the training set data size? Okay, this question is kind of a very tricky question that will come in the interviews. So models with very high bias and low variance works very well on the small data and does not overfit as well, because models with the high bias and low variance are generally simple models that have strong prior beliefs about the underlying data distribution. Okay, so any model who have some kind of a strong prior beliefs about the data, like linear regression, naive Bayes, so these regressions, these kind of machine learning models will have high bias and low variance. They work on the small data very well. Okay, but the model with low bias and the high variance works well on the larger data set, because they can easily understand the complex relationship between the data. They can understand the statistical significance about the data, and it generalizes very well on the unseen data or your test data as well. Example, diseases and trees. Okay, so our next question is, what is Confusionmetrix? So Confusionmetrix is kind of a specific table that is used to measure the performance of a classification model. It mostly used in the supervised machine learning problems only. It has like these 4 columns that tell you about the your actual results and your predicted results, and on base of these 4 columns you can derive many things like accuracy, precision, recall, F1 score, sensitivity, specificity. You can derive all these kind of things from these 4 columns. These 4 columns are true positive, true negative, false positive and false negative as well. And if you want to know more about this Confusionmetrix, I will drop a link in the description about a blog that will completely explain how Confusionmetrix work and how you can interpret it. Okay. So our next question is how you can choose the optimal number of clusters in k-means clustering. Okay, clustering is an unsupervised machine learning algorithm that is used to cluster the data based on their characteristics, based on the patterns that the algorithm can find. But how many clusters you can make? If you can make 3 clusters, then why? Why only 3 clusters? Why not 4? Okay, so the value of k that determines how many clusters your model will make is very hard to find. But if you find it with the very suitable method, your algorithm works fine. Okay, so by using the elbow method, we can decide the optimal number of clusters that our clustering algorithm must try to form. Okay, the main principle behind this method is that if we increase the number of clusters, the error value decreases. The error within the cluster decreases. So after optimal number of clusters, the decrease in the error value is so significant and so linear that we know that after this point, the error will keep on decreasing as well. So the point where your elbow starts going in a very linear fashion is your optimal cluster point. So choose that cluster. If you see in my graph, the point is 3. So after 3, my line goes in a linear fashion. So my optimal number of clusters would be 3. Okay. So at 3, all 3 clusters have minimum squared sum of errors within the clusters, and they have very low inertia as well. Okay. So our next thing is, how do you measure the effectiveness of these clusters? Okay. So once you make the clusters with the help of k-means clustering, find the k value with the help of elbow method as well. Now, how you can measure the effectiveness? So there are matrices like inertia or sum of squared errors or Silhouette score or I1, I2 scores. So out of all these matrices, sum of squared errors and Silhouette score is the common matrix that we'll use to measure the effectiveness of clusters. Although this method is quite expensive in terms of computational cost, because it has to repeat the calculations on all the data points that you have. So the score is high if clusters are formed dense and well separated. So if your score is high, then you are very good and you have very good clusters. If score is low, then you have very poor clusters as well. Okay, so that's how you can measure the effectiveness of the clusters. So the next question is, how do you select important variables while working on a data set? So this is the question from the feature selection. Okay, so you can identify and discard the most correlated variables before finalizing on important variables. Okay, so first you can build a correlation matrix and find out which variables shows the multi-collinearity there, and just remove those features, because all your features should be correlated with the target variable, not with each other. Okay, and then variables could be selected based on the p value from the linear regression as well. If you put a linear regression algorithm on your data, then based on the p value you can decide. Or you can also use the forward, backward and stepwise feature selection as well. You can use the lasso regression as well. You can use the random forest feature importance as well. You can also select the top feature based on the information gain for the available set of the features as well. So these are kind of techniques that you can use to select the important features while working on a data set. Okay, so main first thing, you have to build a baseline model first, and based on your baseline model you can select the features on these methods. Okay, so the next question is, explain one-hot coding and label encoding. So one-hot encoding is the representation of categorical variables as binary vectors. It will return 0, 1, and it can make as many as columns of the 0, 1 as many labels in the categorical variables you have. Okay, and label encoding is converting your labels into the numerical form only. So if you have only one column, you want to convert it into numerical column, so it will just convert it like this. This is your categorical column, this is your column after doing the label encoding. But this is your categorical column. So this will be the numerical column after applying the one-hot encoding. So one-hot encoding will increase the dimensionality of your data set, but label encoding will not. Okay. So the next question is about, this is a kind of a very case study tree question, that a data set is given to you. It has missing values which spreads along one standard deviation from the mean. How much of data would remain untouched? So if you know about this plot, that will show that how data is spread in a normal distribution, then you can easily know that how much data is remain untouched from the missing values. So if it says that missing values are spread from the one standard deviation, that means from this 1a to plus 1a, these are the values which have the missing values. Because the values which don't have the missing values are like this. Okay, so that means 32% of the data remain untouched from the missing values. Okay. So the next question is, what is the difference between the regularization, normalization, and standardization? Okay, so the normalization adjusts the data. You would want to normalize the data if your data is on a very different scales. Okay, this can helpful to make sure there should be no loss of accuracy. One of the goals of model training is to identify a signal and ignore the noise. If the model is given free rein to minimize the error, there will be possibility of suffering from the overfitting. Okay, so in that case, you should apply the normalization because you have very different scales of the data. But regularization adjusts the prediction function only. It impose some control on this by providing simpler fitting functions over the complex ones. If your model is going to the path of overfitting, it will apply the penalty on that. Okay, so only this is the work of regularization here. But on the part of standardization refers to the scaling data on the mean of 0 with a standard deviation of 1. Okay, it will just standardize on this scale only, which having the 0 mean and standard deviation of 1. Okay, this is the difference between all these three terms. Okay, so the next question is, what is kernel trick and in SVM and how it works? So kernel trick is actually a mathematical function that applied on the data points in the support vector machines and can find the region of classification between the two different classes. So based on the choice of function you use, because there are many kernel tricks available like linear, radial, RBF, there are many kind of things are here, which completely depends on the distribution you have. So it will just take your data and make it from the 3D to the 2D dimensions. So if you see this, then data is actually very hard to classify. But if I just apply a kernel trick on that and make this data into a 2D shape, then it is very easy to understand because I can easily fit a plane right here, right? If I fit a plane right here, then I can easily classify all the points on the red side and on the green side as well. So this is how the kernel tricks actually works. So if you have very complex data which you don't know how to classify, you should apply the kernel trick on that. It will decrease the dimensionality of your data. Okay, so the next question is, why boosting algorithm is more stable algorithms as compared to the ensemble algorithms? So actually the boosting algorithms focuses on error found in the previous iteration until they become obsolete. Okay, so as you just see, it learns by sequential learning. So the errors of one model will be resolved by the other. So in that way, at the end, all the errors will be gone into a corrective loop until all errors got fixed. Okay, but in the form of bagging or ensemble learning, there is no corrective loop. So that's why boosting algorithms are more stable as compared to the ensemble algorithms as well. Okay. So our next question is about, what do the terms prior probability and the marginal likelihood means in the term of Naive-Bayes theorem. So if you know about the Naive-Bayes theorem, you know about this formula as well. That shows that if you want to predict the posterior probability of a hypothesis given that the evidence is true, you should use this, that you know about the likelihood of the evidence given that the hypothesis is true, multiply by the prior probability of that hypothesis and divided by the prior probability of that evidence is true. So if you know about this formula, then this formula completely explains that the prior probability is the percentage of the dependent binary variable in the set. If you are given a data set where the dependent variable is either 1 or 0, and percentage of 1 is 65% and percentage of 0 is 35%, then the probability that any new input for that variable of being 1 is 65%, right? So if you can take a new variable, the chances of that data point to be 1 is 65%, and marginal likelihood is the denominator of the base equation. It makes sure that the posterior probability is valid by making its area 1. Okay, so because probability is always between 0 and 1, so marginal likelihood will take care of that, so that your answer will always comes in between the 0 and 1. Okay. So the next question is, what is model accuracy and model performance? Which one you choose and why? Okay, so this is the a senior level question that you can be asked in the machine learning interview questions as well. So when we talk about the model performance, it can mean very different things. If we are talking about how fast a model works, it depends on what the model is used for. For example, if it's a real-time application like a search speed, okay, so speed is super important if we are searching something, if we are uploading something. Okay, so imagine waiting for the results of your search or the uploading. So it does not fun, right? But there is another side to performance as well. Sometimes accuracy isn't the only thing that matters. In situation where data is not balanced, okay, accuracy is misleading there. So instead we look into the accuracy, we look for the F1 score, because F1 score is the harmonic mean between the precision and recall. That will take care of the false positive and false negatives as well. So it's not always about the speed, it's not always about the accuracy, it's always about the situation and the problem you are dealing with. You should not stick to one thing, performance or accuracy. You should stick to the business problem only. Okay, so our next question is, how ROC curve works? So the graphical representation of the contrast between the true positive rates and the false positive rates at various thresholds is known as ROC curve. It is used as a proxy for which trade-off between the true positive versus false positive will look like. So the closer the curve to the 45 degrees, the diagonal, the less accurate the test. Okay, so if you just see here, so if my curve is farther away from this 45 degree diagonal line, my model is good. So that means this red line model is far much greater than the green line model and then the black line model as well. Okay, so in that way you can interpret multiple models on this ROC curve as well, and you can know their classification power as well. Okay, so our next question is, what is data leakage and how we can identify it? So data leakage in machine learning occurs when information from the testing or the validation data set is unintentionally included in the training data set, so that lead to artificially inflate the model performance. To identify it, you can carefully examine your feature engineering and data pre-processing steps, ensuring that the information from the test set does not influence the training set as well. So additionally, consider cross-validation techniques which can help detect data leakage by revealing if your model performance significantly better on validation set compared to the unseen data as well. Okay, so that usually occur when you apply any kind of feature engineering steps on your training data as well, and on your test data, same kind of steps on your test data as well. So in that way your data leakage will happen. But if you try to do it separately, the data leakage will not happen. Okay, so that's all from this video, and I hope you guys really like this video on all interview questions as well. So if you guys want to know about any more interview questions or any other machine learning or data science topic as well, you can pin down in the comment section, and I will surely make a video on that You can also check out my machine learning algorithms playlist as well, in which I already wrote about the regression algorithms are completed, along with the tree-based algorithms as well. And next, I will start with the classification algorithms from tomorrow. Thank you so much. And if you need any help, you can always send an email to me, or you can also watch my blogs on the Medium as well, which you can learn about the machine learning, deep learning, statistics, and Python, along with the generative AI as well. Thank you so much.